piece of paper. I don't know, if we talked about reading scales. I don't know. So right on top, scales, I guess. When we talk about reading scales, I don't know if there's a good way to define reading scales or not, but some of the things that are scales, and again, in our digital world, a lot of this stuff gets thrown out of the water here. Thermometers are scales, or usually when you say, if your mom said to step on the scale, that would be like a bathroom scale. But again, most of those have just numbers on them, and you don't have to really read the numbers. It just tells you what it is. But one that you do have is your ruler is also a scale. It is something that's been divided up into different pieces. You know, a line that's been divided into equal pieces, I guess it is. And the first thing we're going to talk about is a thermometer, even though, again, I'm not so sure if any of you... See, when I was a kid, young children, we used to have what we called thermometers, which were these little glass things that told you the temperature outside. And the beauty of it is, if you accidentally broke it, out would fall some very dangerous stuff called mercury, which is very dangerous to play with, and I always told you not to, and I don't think I ever did. But people liked it because it was really bizarre, because when you drop it, it would like splat, but it would splat like little balls all over the place. And those little balls, you could push them back together and they become another big ball or whatever it is. But all the good days of playing with all the stuff that was bad for you, they just don't let you do that anymore. But let's talk about temperature first when we talk about scales. And usually you get the standard textbook thing that looks like this. You've probably never seen a ball thermometer, which is what this is. Maybe Mrs. Stone has one. You should ask her. You know, and then it has little red liquid in it that goes so high or whatever. If you haven't seen one for real, you've seen one in other math books or science books or whatever there. But when we talk about temperature, we have, unfortunately, again, two different units of measurements. Do you know what they are? And we're going to write the words down. So I want you to be able to spell this. One of them is, Trevor,
Fahrenheit.
Fahrenheit. Let's spell that. And it's in your book on page 166 if you want to see it. Fahrenheit, named after Mr. Fahrenheit, I'm sure. Fahrenheit. And that's what we use all the time in America, because, again, we're pretty much, I don't want to call us, I'll just say we're silly, because that's a good word for it. I don't know why we do that. And in the Fahrenheit scale, both of them use degrees. Water is a very important thing when it comes to temperature, because we base a lot of things on water. One of them is the temperature at which water freezes. What temperature in Fahrenheit does water freeze? Everybody seems to know this one there. Maggie?
32.
Right. At 32 degrees, water freezes. And by the way, water is one of those things we never really appreciated, but it's one of the very few substances that we see in all three states. It's gas state, it's liquid state, and in its solid state. When it's ice, it's a solid. When it's water, when it's a liquid, and when it becomes steam, it becomes its gas. I believe all things, given the right temperatures, will change into that. I mean, you can make anything hot enough that it becomes steam and completely evaporates or melts or whatever. What is the temperature at which water then boils and becomes a gas, Colton?
206.
You're close. 212 degrees. Water boils. Okay, and then you go another 32 degrees here, you get 0 degrees. And then you have below 0 kind of stuff down here. Now, the other scale we use is, anybody? Brian?
Celsius.
Yep, Celsius. Also called centigrade, but Celsius is its most common name. And now here's what, if you were being a smart person making your own scale, this guy, Mr. Celsius, or whoever he was, I don't know if it really was a name, okay, if you were thinking about this, what logically degree, if you got to make your own scale, logically you'd say water should freeze at what temperature? Logically, let's just make it Colin, 0, and that's what he did. 0 degrees is where water freezes. Which makes sense because, hey, let's just make that easy. And then, water then, if that's the case, water then boils, what would be the next? I suppose you could say 10, but let's not do that. Let's make it a little higher number to give us a few more increments there. Water boils at what degrees Celsius, Jordan?
100.
Yeah, 100 degrees. That's water boiling. And then you've got all the things there. Now, if you know that, looking at those two scales, if you go up 1 degree Celsius, would you be going up more or less than 1 degree Fahrenheit? In other words, if the temperature went from 1 to 2 degrees in Celsius, or 1 to 2 degrees in Fahrenheit, which one did it go up more? That's a thinking question there. That's a really thinking question there. I think they have some sort of idea. Victoria? Fahrenheit, you think it goes up more. Anybody agreeing with that? How many people think Celsius? Well, let me ask you the question. Between 32 and 212, which scale is going to have more degrees? So if there's more degrees, that means it can't go up as much as fewer degrees. Here there's only 100 tick marks to go up 100 degrees. Here you have 180. There's 180 here, so there's a whole bunch more that go up the same amount. So Celsius actually goes up more for every one thing. You know, how about this? What on a relatively warm day? How many degrees Celsius would a relatively warm day? I mean something not super hot, but not super cold either. What would you say on a relatively warm day? How many degrees would you say it is? Celsius. Okay? 50 degrees Celsius would be halfway between here and there, which would be 90 degrees, would be like 130 degrees. Probably maybe even more than that. 50 is extremely hot. We would never on Earth actually get to that temperature, I don't believe.
Except for in the center of the Earth.
Well, on the surface of the Earth, yes, we could probably go to the sun too and achieve just about any degree. Addison?
39.
39 degrees is fantastically warm as well. Fantastically warm as well. And again, let's put this here. Let's say a warm degree is about 80 degrees. Let's go 80 degrees Fahrenheit would be close to how many degrees Celsius? And we probably should look. Is there a scale on here that has them both? Maybe they don't. Because I don't want to mislead you there. Is there one? Although they do match up. Yeah, they do match up. You're right. Looking at that there in the book there, somebody got another suggestion there, Colin?
Like 25?
Yeah, probably 22, 23, whatever. 24, whatever degrees. Not very much. That's a pretty warm day. And if you look actually on your book on page 166, they do kind of measure up. 20 degrees Celsius is about 68 degrees Fahrenheit, so you can kind of base something on that. Now, what you need to do also in scales is write this down here. Anytime you're looking at any scale, okay, when you look at any of this stuff here, you must figure out what each scale mark stands for. And you won't understand that until we actually draw something up here. I should look. I think I had. Maybe I do have something. Hold on a second. Through the magic coin of the beautiful big board here. Do you think I actually have something?
Yeah.
No, not that organized. Oh, I see math. Where did math math. And you guys are what? Let's go find stats in here.
There's a lot of teacher.
I know. I wish I was organized to keep it all straight here. Max, you guys are 5th grade. Oh, look at! How about this guy? Am I prepared or what?
Yeah.
What? What should be the answer? The question is if it'll actually come up. Come on. 5, 4, 3.
0.
Now, here we go. Check this out. Hold on. Okay, here's what I talk about when I say such things as I just said that I thought I said right here. All right, so here you have. I don't know if you've actually come up with a thermometer here before. Maybe you've seen something like this. Maybe you haven't.
Yeah.
But when you look at a scale, which this is a number, it's like a ruler, cut into little pieces. Your first job, ladies and gentlemen, is to look and say, okay, this red line goes one little niche mark after 80 degrees. Okay? You cannot assume that it goes in increments of 1. You can't say that's 81 degrees until you have looked at, and I'm going to blow it up so we can see it pretty big. That hurts my eyes, but it's going to be close enough. Okay, here's 80 degrees. How many degrees is this? 90, because 100's up there. So, between 80 and 90 degrees are how many spaces is what you should count. 1, 2, 3, 4, 5. There's only 5 spaces between there. So every space has to be how many degrees? 2. So when the line goes up to here, when the line goes up to this point here, even though it's kind of deep, it's not 81 degrees, but 82 degrees. And the same thing here. Okay, take a look at this. This is 20 and 30, correct? So this is 25. So between 25 and 30, there's 1, 2, 3, 4, 5. So on this side over here, every mark is how many degrees?
1.
Just 1, because there are 10 between 20 and 30. So this is 25, 26, 27, 28 degrees. 82 degrees is the same as 28 degrees in Celsius there. Now, I know you're kind of saying, what about something else, you say?
What about something else?
Here's an actual scale here for real. A bathroom scale, which, does anybody actually have a bathroom scale?
Yes.
An old-fashioned one nonetheless, not a digital one?
I have one old-fashioned and one
I don't know if I can actually take a look at that scale there. Let's forget that one. Let's go to the other ones. Because you can't see the numbers and I can't see the numbers. Take a look at this one. Let me make a copy of it. Put it up. It's asking what the weight of this one is. Oh, that is big. So, you can't just, what I'm telling you, 5th graders, is the first thing you need to go to say, what does each tick mark stand for? You can't say that this is 201 and 202. They're not that, because you would only get to 205 here, and this is 300. So you need to figure out what each one of these spaces do. So the way you do that is go, well, from here to there, from here to here is 100, right? So I'm cutting 100 into how many pieces up here? 1, 2, 3, 4, 5. If you take 100, cut it into 5 pieces, Marilyn, each piece is 20. So this is 200, this is 220, this would be 240, 260, 280. And that's what I mean when you look at scales, you have to do this. You have to figure out what each little mark stands for. Otherwise, you'll get Mr. Incorrect answer. So, take a look. Open your book to page 167 for me, please. 167, are you there? Look at practice letter C. It says points A and B on this number line indicate two numbers. What are the two numbers? Point A is what number? Point A. So you have to figure out what each notch is worth before you jump on whatever bandwagon. Jacob, it is?
30.
30 is correct. And point B then is? Maggie?
80.
B is 80. You are absolutely positively correct. Yeah. So I think, hopefully, ladies and gentlemen. Hey, flip to page 168 just for fun. How about problem number 14, which will be part of your homework? What number does that arrow on that scale point to? What number? It takes a little time to look at what, I mean, you got 200, 400, there's a 300 in there, and then blah, 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 yada, yada. Brooklyn?
350.
Very good, 350. 350. I think you got it. Very